All right, so mean and standard deviation. So for binomial, we've talked about this one. And we have talked about it, but we're going to look at it for emailed it. How do I find the mean of a binomial? N times B. How do I find the standard deviation of a binomial? Because I'm also considering failures there. So that you should have seen before. If I flip it 7 times, my expected value is 3.5 because on average in the long run, if I did it 7 times over and over, I would expect the average amount to be about 3.5 tails. I am going to show you this piece of paper at one point in time. You can use this on the AP exam, and it gives you a bunch of equations, but it doesn't tell you what they go to. And that is on here. So it also gives you 1, 2, 3, 4, 5, 6, 7, 8 equations for standard deviation on here. So like you would have to know that that's the one that it applies to, but eventually I'm going to let you use this. But we're just not there yet. With geometric, so this one with average is how many I would expect in the long run after that many trials. Now with geometric, what do you think the mean would actually stand for? Like it makes sense with binomial if I haven't even talked about binomial, what the mean is. What do you think that the mean is for geometric? The average number of trials it would take to get your first success. So if I flip a coin, which is 0.5, what do you think the average number of times I need to flip a coin is before I get my first success? 2. So how did you get that? What is the probability of success? And what did you do with that? What is as a fraction? 1/2. So how do I get that? Flip it over. 1 divided by probability. Probability of something's 20%. Would expect about 5 times before our first success. Now, geometric is not on here with mean and standard deviation. Mean for geometric is pretty easy to remember, just being 1 over p. The standard deviation one is not as easy to remember. Wow, they don't even have it in here like that. So much so that the book didn't even put it with the summary, which is weird. Okay, well, I might just talk about standard deviation separate if they didn't even put it in here. Okay, we'll just start with those then. There's a couple problems that I'm having you do today that say and standard deviation, but just don't do standard deviation for geometric right now. So when we flipped a coin, or flipping the coin, just so that we have stuff to go with it. When we flipped it 7 times, we did 7 times 0.5, which equals 3.5. What do I need here? I want to see N times P too. What do I need with my answer? Units. What should I put with 3.5? Flips, tails. So like units, I can interpret this one correctly as like flips, because 3.5 of the flips would be tails, or put tails like your units could be a little bit more flexible than usual. N times P times 1 minus P, square root of that, because I want standard deviation. So square root of 7 times 0.5 times 0.5. So I type that in, what do I get? And then if I'm doing it for geometric, just because we talked about both of these. Now, it would make more sense here to say what is my units, generally. Because it's how many flips until we get our first tail, so maybe 2 flips would have been better up there, but I mean, I'm fine with the way it is. So this is, on average, how many it would take before we get our first success. This is, if we flipped it 7 times, we would expect an average in the long run of about 3.5 would be tells the standard deviation of that. I'm going to talk about interpret again. I'm going to talk about interpret for the first time tomorrow, but it works the same way as our interpret with those spinning forms. That's what, but like, if we're talking about money, it's going to be money either way. So like, does that make, it's like talking about, it's like sometimes yes and sometimes no. These are more flexible than they usually are because of that, and they're technically working correctly. As long as I need to see this to see that you're not like way off on the wrong tangent.